Hey guys, welcome back to my channel all about architecture, where I make videos related to architecture equipment and architecture nodes. So today we are going to start the first video on architecture nodes, and these nodes would be helpful for you for your academic purpose, or if you are studying for GATE exam or any type of PSU recruitment exams. So in my videos I have tried to create detailed notes of each and every topic. So the first topic which we are going to study today is fire safety. So fire safety comes under section 7, that is services and infrastructure. If you guys haven't seen my first video related to architecture syllabus where I had divided the topic according to sections, if you have seen it, it will be easy for you to study according to topic under different section. After watching, please note down all those topics. It will be easy for you to study. Now let's begin the video. So let's have a quick overview of today's class. Firstly, we'll have a small introduction to the topic of fire safety. Then later on, we'll classify the fire on the classes, different classes. Then we'll study about grades of fire hazard. Then have a look on terminologies according to NBC. Later, let's study about classification of building according to fire load, some of the fire detection system and fire extinguishing system, and learn about OSHA, that is Occupational Safety Hazard Act, and later learn about fire protection requirements for multi-story building. So I have listed down these topics based on their importance in GATE exam and other recruitment exam. So these are important topics. I have tried to make a detailed notes on this. So now let's begin. Firstly, we'll have a brief introduction on fire safety. Basically, fire safety is a set of practices intended to reduce the destruction caused by fire. Fire safety is a set of practices intended to reduce destruction caused by fire. I would suggest you guys for NBC 2016 Part 4 from Volume 1 for more information about the fire safety. So let's discuss about the classification of fire. There are totally 4 to 5 classes of fire. Let's discuss one by one. Class A fire. Fire caused easily due to combustible or solid materials of organic nature such as wood, brass, paper, cloth, etc. If the fire is caused through this material, then it's called as Class A fire. This is an indication mark for Class A fire. Next is Class B fire. Fire caused by volatile or inflammable liquids like example petroleum products. So this is Class B fire caused due to petroleum products. Class C fire. Fire involving flammable gases under pressures like including liquefied gases. Fire caused by liquefied gases like LPG are classified in Class C fire. We usually use this in cooking. Class D fire. Fire involved in evolution of heat by chemical reaction in combustible metals such as magnesium, aluminium, zinc, sodium, potassium are classified under Class D fire. Like combustible material like aluminium, zinc, etc. are classified under Class D fire. Usually they denote in this manner. So GATE or any other exams can ask the questions regarding classification of fire in the form of neither following. They can give you the classes and these type of symbols. You need to match them. Like even they can ask like under what class the liquefied gases comes. You just need to match them. In this type, the questions can be asked. So let's move on to the next topic, that is grades of fire hazards. Before that, let us know some of the common fire hazards. Fire hazards can be caused in kitchens during cooking, frying, or due to some electrical misconnections, etc. These are some of the common fire hazards. So let's grade the fire hazards. So basically, there are three grades of fire hazards. First is personal hazard, is loss or damage to a human life. If there is a loss or damage to a human life, it is considered as personal hazard or damage to a human life. Second is internal hazard. Basically, internal hazard is fire spread inside a campus or a building. So, spreading a fire inside a campus or a building. Third one is exposure hazard. This hazard is due to exposed fire accident. Like example, spreading of fire from adjoining building or a campus. Exposure hazard. Spreading of fire from near building or adjoining campus. So these are three important grades of fire. So let's move to the next topic, that is terminology, which is a very important topic. For terminologies, I would recommend you guys to just go through once through the NBC 2016 fire safety part, so that you'll come to know some of the important terminologies from there. So let's discuss about fire door. There are 4 important hardwares for fire door. Important hardwares. So first is this glass. This is see-through glass, so that you can check in case you have fire in that particular area through the glass before opening the door. Second is this push bar to open. It's also called as panic bar. And third is this hardware here. It's called as automatic spring closing mechanism, which opens and closes immediately and stop the flow and spread of fire to the other parts of the building. And the fourth part is which is like hidden part. You have a strip kind of band surrounding the door, so that there should not be any leakage of smoke from one end of the door to other end. It's called as intermittent strip. It stops the spread of smoke. So first is, as we discussed, that is see-through glass, see-through visibility glass. Second is automatic spring closing mechanism, which is this part. Third is intermittent strip, which helps to stop the spread of smoke or leakage. And fourth is push bar or panic bar. So guys, this visibility glass has 120 minutes fire resistance. These are 4 important hardwares regarding to fire door. The door which we are using for fire exit should be fire resistant door with minimum of 120 minutes fire resistance, almost 2 hours of fire resistance. And this door should be provided along the means of egress. This is an important term. This question can be asked. It is like means of egress. Basically, it's a path of exit. This exit can be near staircase or corridor. So fire resistant door should be provided near the means of egress. So these are few important points regarding to fire resistant door. So let's move on to next terminology. The next terminology is fire tower. Fire tower is basically an enclosed shaft having protected area. Enclosed shaft having protected area of 120 minutes of fire resistance. So fire tower comprises of protected lobby from staircase and fireman's lift. Usually fireman's lift is nothing but a lift which is used only in case of fire accident. Fire tower is also called as firefighting shaft, and all the entries for fire tower are given using fire door to maintain the safety of that shaft. So this is about the fire tower. So next, let's discuss about fire load. Basically, fire load is a total load content in that particular space. Like example, consider a room. If this is a room, it contains 4 walls, one ceiling and other is floor. The materials used on the floor, on flooring and 4 walls and the ceiling all contains a standard value of called as calorific value. If there is any partition in this area, in this room, it also constitutes to fire load. So basically fire load is calorific energy of the whole contained in a particular space or room, including 4 walls, floor, ceiling, partitions, or any type of components placed in that space, all constitute to fire load. So unit for fire load is joules, and to calculate fire load density, the unit is joules per meter square. So what is calorific value? Calorific value is nothing but it is amount of heat released by complete combustion of 1 kg material. So almost every material has its own calorific value. So unit for calorific value is joules per kg. So amount of heat released by complete combustion of 1 kg of material. So this is the unit of calorific value. Next terminology, that is fire triangle. So basically fire is caused by 3 main elements, that is heat, fuel and oxygen. These are the main 3 elements which causes fire in any sort of fire accidents. So this is a fire triangle. So for example, they can ask in MSQ questions, pick the 3 main elements constituting fire. So they can give you 4 options and 3 will be from this. You need to select these 3. So next move on to the next topic, that is classification of building according to fire load. So there are 3 main classification. First is low fire load. The fire load with 2,75,000 kilocalories per meter square are considered under low fire load. Usually this can be seen in domestic buildings, hotels, offices and similar type of buildings. So next is moderate fire load. In low fire load, the load should be less than 2,75,000 kilocalories per square meter. In moderate, we have load from 2,75,000 to 5,50,000 kilocalories per meter square. These are usually found in factories and any type of trading industries. And the next is high fire load. The fire load exceeding 5,50,000 kilocalories per meter square to 11 lakhs kilocalories per meter square are referred in high fire load. Usually with the serious in go downs and etc. So these are 3 main fire load and the classification of building according to it. So next topic is fire detection system. So first we'll discuss about fire alarm. Basically fire alarms are installed in a building providing warning signs to the occupants of that building that there is a fire break in the building. So there are two types of fire alarms. One is manual fire alarm system. In manual fire alarm, it consists of hand bell or similar sounding device. Basically, there will be a hand bell usually installed near the main exit and passages. So a person goes and rings that alarm or bell in the event of fire breakthrough. And second is automatic alarm. So usually they are in this type. They are installed on the ceilings. They detect the smoke. In case if there is any kind of smoke or fire, it detects it and the alarm rings. And this kind of alarm is called as automatic alarm. Firstly, the smoke is detected, and the fire alarm rings. So these are fire detection systems used in buildings. So now let's move on to next topic, that is fire extinguishing system. There are various fire extinguishers. First we'll discuss about manual fire extinguishing equipments. Most of you all have already seen this picture maybe. This is nothing but fire. This is fire extinguisher. Usually these are placed near to the lift well or in the parking or near the electrical room. These type of equipments are portable. If there is any fire accident, they use these extinguishers. This produces large amount of foam which stops the fire. You have seen a bucket filled with sand and water placed in parking also helps in reducing the fire. So this is about fire extinguishing equipment, which is manual. Next is fire hydrant. Hopefully you have all seen this on the roads, on the edge of the roads. These are placed outside the building. There is a connection of pipeline from underground, or there may be a underground tank. So whenever you open the hose, pressurized water comes out from this hose. We can connect this hose with a pipeline for proper spraying of water. Fire sprinklers. Fire sprinklers are usually placed in parking. Fire sprinklers are usually placed on ceiling or on slab, below the slab. We have this type of connection, continuous connection of sprinklers. Normally the diameter of the pipe will be 20 mm. The distance between each sprinkler should be maximum of 3 meters. One sprinkler can cover up to 10 square meters of area, spraying the water. As we can see this red thing over here, this is made up of glass. Whenever there is any fire accident, this glass melts and starts sprinkling water. And this part starts rotating. So water gets sprinkled all over the area, about 10 square meters. So this is about fire sprinkler. These are few of the fire extinguishing systems. In fire extinguishing, we have firefighting systems that mainly those are 3 types. First is wet riser system, downcomer system, dry riser system. I'll try to explain with the help of a diagram. This is a building with multiple floors. In wet riser, usually you have the tank underground. In downcomer, this is a building with multiple floors. You have the tank overhead. In case of dry riser, you don't have any kind of tanks here. The source is external. Water supply should be from external device. So for wet riser, water is sent from below with the help of electricity, that is pump, with the help of pump to each level. In case of overhead, you don't require pump. With the help of gravity, the water gets supplied. Only for filling the tanks, you require the pump. So by seeing the diagram, we can see that in wet riser, there is no dead load on the building. In this, water is readily available, always available. So its name is wet riser. But we require pump. This uses electricity. In case of any fire accident, if you don't have electricity supply, then this becomes difficult to handle because you need to pump the water to all the floors with the help of electricity. So we have one disadvantage in this. Usually this is best for flats and apartments. In case of downcomer, this works on gravity, but this adds extra load. This has more maintenance issue compared to wet riser. In case of fire accident, if you don't have any electric supply, this downcomer system works best. Usually these type of systems are used in low-rise buildings. Next is dry riser. Here the water is from external source, but no maintenance is the main advantage. No maintenance is required, no wastage of water. But this type of system relies always on external supply. This depends upon fire tender. These type of systems are used in institute, malls, mall buildings, etc. This is about firefighting systems. The short form for this is OSHA, OSHA. This provides us with some color code of fire safety. Let's discuss about the different color codes and their description. First is yellow with black. This indicates physical hazard, physical danger. Second is orange with white, mainly for traffic warnings. Fluorescent orange or red orange. This is for biological hazard. Purple or magenta with yellow for radiation hazard. Red is for fire protection equipments. Black is for housekeeping and eye marking. Seventh is green with white for safety and first aid. Blue with white is for defective machineries. So guys, these are important code because GATE has already asked questions on this, so you need to note it down. They may ask this in the form of match the following or as an MSQ question. So this is an important topic in fire safety. So let's move on to next topic, that is fire protection requirements for multi-story building or passive fire protection. First passive fire protection is calculation of exit width. These exit width are calculated for doors, ramp, staircase, corridor. For calculating exit width, first we need to calculate the number of occupants, which gives us occupant load. So make a note down of this table. This is an important table as per numerical part. Questions can be asked from this table. Occupant type, occupant load factor, meter square per person. For resident type, you have 12.5 meter square per person occupant load factor. For educational building, you have 4.0. For institute or business building, you have 10 as occupant load factor. Next step is calculating exit width per person. Sorry for the drawing. Occupancy type, occupant type, width per person, that is in mm. For staircase, we have other width, and for doors, ramps, corridors, we have other width. For resident, education, assembly, and business. So the exit width per person for staircase should be 10 mm per person. And for a door, ramp, and corridors, we need to have 6.5 mm per person. For institute building, it's 15 mm per person for staircase and 13 mm per person for doors and ramps. Make a note that minimum width of all this should be 1 meter, that is 1000 mm. Thus, this is important table as per numerical problems. You need to have this in mind. In question, they may give you the occupant load factor or the minimum width. But in case if they don't give, you need to have an idea of these numbers. This was about exit width. Let's solve problems on this in my next video, where I'll solve previous year GATE and other recruitment exam questions with some numerical questions. Next is doorway. Doorway should be minimum of 1 meter or 1000 mm. For assembly building, you need to have 200 mm, 2000 mm, that is 2 meters. This is important. All these terms are according to NBC, which we are reading on passive fire protection. And the minimum height should be of 2 meters for all this type of doors. Next, we'll discuss about staircase. What type of staircase to be provided in? What are the standards for staircase designing? Minimum width should be 1 meter for residence, 2 meter for assembly, and 1.5 meter for other buildings like schools, education buildings. The thread should have of 300 mm and riser should be of 150 mm. And in a staircase, minimum we need to have 12 steps. Maximum we need to have 12 steps. We should not exceed about this. After every 12 step, we need to give a landing. This is an important point. Number of risers shall be limited to 12 numbers per flight of staircase. This is about staircase. These are standards from NBC. Next, we'll discuss about travel distance. Consider this is your corridor or lobby. If this is your staircase or exit door, the maximum distance should be restricted to 30 meters, not more than that, so that occupants can run easily with minimum distance. So maximum travel distance for exit shall be 30 meters. This is maximum. You should not exceed about this. In case of dead-end corridor, if this is your dead-end corridor, the distance should be maximum of 6 meters. In case of dead-end corridor, should be of 6 meters. This is for education and assembly building. For other buildings, dead-end corridor can exceed till 15 meters. So this is about travel distance. Next, we'll discuss about the ramps. For ramps, the slope should not exceed 8%, that is 1:12 ratio. Consider this is your RAM, this is rise, this is run. This should be in 1:12 ratio. This is 12 meter run and 1 meter rise. So slope is nothing but rise by run. This is an important formula in many of the topics of different sections. We can find this formula in case of landscape and other topics. We need this formula to solve the NAT problems. Important point is that every landing in ramp shall not be less than 150 mm in direction of travel. This is about ramp. So these are few standards which need to be followed during designing of any type of building. So guys, I have tried to complete maximum part related to fire safety and try to make a detailed notes. So if you guys have any sort of doubt related to today's topic, please comment down below and watch my next video related to fire safety numericals, where I have solved numerical problems and previous year question papers with some new questions. So that's all for today's class. If you guys like this video, please subscribe to my channel and give a like. And thank you for watching this video. Have a great day.